This is lesson 10-5, graphing square root functions. Let's talk about what square root functions are. Square root function is any function that contains a square root with the independent variable. We know the independent variable that we use is typically x, and that variable is in the radicand, meaning that it is underneath the radical sign. Graphing square root functions takes on a similar technique to that of graphing absolute value functions. If you do not remember how to graph absolute value functions, you should refer yourself back to lesson 5-8. And the graph of a square root function looks like 1/2 of a parabola. Recall that anytime you have negative numbers underneath a radical sign, it produces imaginary numbers, meaning they are not real. In this course, since we only deal with real numbers when we graph, it's important to understand what the domain will be every time we graph a square root function. Since the lowest range value, or y value, we can have is 0, we could set the function equal to 0 and solve for x to find the lowest domain value and write the domain. Here's an example. Find the domain of y equals the square root of x plus 3. So what I'll do is I set the function equal to 0. I then square both sides. So 0 is equal to x plus 3. Subtract 3 from both sides, and I get -3 equal to x. That is the lowest value that we can have. So my domain must be greater than or equal to -3. This is my domain. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. Here are your answers. X can be greater than or equal to 0 for the first one, and x has to be greater than or equal to 4 for the second one. Let's review our parent function vocabulary. A parent function is the simplest type of any graph. The parent function for square root functions is y equals radical x. Graphs change based on operations that are performed to the parent function. The act of changing any graph to a parent function is called translating the graph. Let's take a look at the graph of a parent function of a square root function. Let's fill in the boxes. Y equals the square root of 0, y would be equal to 0. I picked values that will give me perfect squares to make my points very easy. After completing this, I will then connect the dots in a curved fashion. So 0, 0, 1, 1, 4, 2, 9, 3. Try to keep your graph as curved as possible, and you're only in need for one arrowhead because remember, the domain of our function starts and cannot go any lower than 0. Remember to always label your functions on graphs. Create this chart for yourself and see what happens when you do different things. We'll take a look at what actually happens on the next slide. Pause the video at this point to allow yourself to create the chart, and then take a look at what would happen when you add or subtract different numbers. The chart should be filled in as such. When you add h to the outside, it moves up the graph h units. Your function would then look like y equals the radical x plus h. Remember, h is simply just a number. When you add h to the inside of the radicand, you move it to the left. When you subtract h from the outside of the radicand, you move it down. When you subtract h from the inside, you move it to the right. Square root graphs can be one or more translations of its parent function. Order never matters when you're describing or graphing translations. Here's an example. How does the graph of y equals the quantity radical x minus 1 minus 7 differ from its parent function y equals radical x? It's going to move 1 to the right and down 7 units. If you said down 7 units and 1 to the right, you're not wrong. The order doesn't matter when you're describing a translation. Here's a graphing example. Let's graph this function and explain how it relates to the parent function. The plus 1 on the inside tells me that it's going to move to the left 1 unit. The minus 4 on the outside tells me it's going to move down 4 units. So from 0, 0, I'll go down to negative 1, negative 4. So on and so forth. 1, 1 goes down to 0, negative 3. 4, 2 goes down to 3, negative 2. And 9, 3 goes down to 8, negative 1. Connect my dots with a curve. Label my function. And describe my translation in words. The graph moves 1 unit to the left and 4 units down. If you're having any issues with this particular lesson, please consult your teacher in class.